Everybody. Hopefully this is just a blip for those of you who actually sat through my 2 minutes of going and getting water. Uh, but yeah, this will help me organize the video slightly better. Hello. We are continuing to work in Gas County. Last time we were doing a somewhat exciting session. We finally feel like we know enough about packs to start refactoring our city. In terms of packs, packs being the unit of modularization for agents and formulas and related stuff inside of Gas City. And we were working on looking at the existing Gas City packs. So this would be things like uh, features that other people have already shared with the community. Some of them help agents just work a little better, a little faster, that kind of thing. Interesting. Um, I'm noticing on the terminal, last time this happened, I wasn't able to type into the terminal anymore. I think it's happening again. Let's just make a new one. And I don't totally care why it's happening. Just want to get past it. All right. But yeah, so we're asking our mayor to draw up a plan to remodularize our city. We talked about the rig city boundary, the fact that we have a bunch of rig specific agents, and it proposed that we should leave all the configuration for those agents inside of the rig itself. And I think that there's going to be an interesting way to do that. So the rig will sort of declare its own pack, and it will have all of this agent configuration and things like that. And then the city is going to pull them in by reference and then start talking about them. And so where we last left our mayor, it had created a big plan in beads to start pulling things out and refactoring them. And then after it pulls out the puzzle project that we're working on, then, oh, hello. Okay, there's a lot of stuff that we didn't have here. Okay, this is the last thing we said right here. So I think this is where we left off last time. Um, yeah, so we're waiting for a lot of things, but we're sort of we want to refactor our rigs, and we had some things in flight on some of the earlier agents. We'd like to get the tutor itself into a repository so that we have a better chance of guarding against data loss. And finding the shareable nub too. I kind of spoke about this last time, but when you're working on a proprietary project, you want to have a sort of fence in between your trade secrets and your copyrightable proprietary stuff, the stuff that's unique to your business or that distinguishes you from your competitors, and the stuff that is kind of like solving a generic problem for everybody. And you know, if you're super super far ahead of the pack, then solving generic problems might be some kind of competitive advantage. But if it's just something that's kind of in the air, you want to give it back to the community and let the community help you maintain it if it's any good, if it's of general interest. Okay. Yep. So this is we decided to put the rig basically as a sibling of the city directory instead of underneath the city. So that's a big change. We hadn't done that in the past, but probably it would have been fine if we'd started from the beginning and done that. I guess we could have considered making a rigs directory too. Dan, Gas County, rigs, incremental. There's a Git repo rooted in this directory, but I don't think it's going to be an issue. Moving that root around on your disk shouldn't make much of an issue. Okay. Okay. Rig list shows the new location. We're resuming this antiquarian to see if we could get its work done. And what it was doing was bringing in a whole bunch of puzzles from the puzzle repository run by, I want to say, Angela and Otto Yanko. Great. All right. We can do a get init at the city tutor city root. It's asking if we want to do that. I should make a private repo for it while we're talking about that. Um, and it's weird that we called our city tutor, but you know, it's fine. All right, let's add that project. Private repo, don't add anything. Cool. All right. Oh, good. The relocation to just preserved state. The antiquarian woke up and it completed 243 entries. That's great. Um, it wants to wake up the simplifier. I mean, yeah, this is one of those interesting like we were talking about this the other day. Uh Maybe I was talking about it in a different context as well, like a different conversation. I was. There's a funny video that I saw the other day that's sort of about uh somebody asked the AI a question about like Pythagoras's laptop, right? And you know, it's like this counterfactual history, right, where um, you know, what would be the problems if Pythagoras's laptop wasn't security patched up to the present? And the AI sort of gamely tries to answer that question, and it constructs a world where Pythagoras has a laptop, and you know, his secrets could be leaked to its philosophical rivals, and you know, maybe his cult would fall apart or something like that. But in the middle of its answer, it also talks about the Pythagoras CAD software, and it turns out that there is such a software. It is like a professional CAD CAM suite called Pythagoras, and you can see pretty clearly if you know that context that the agent was trying to answer a question about Pythagoras and it got confused about which one was being referred to in the middle. It didn't maintain that continuity of semantics or something like that. And that's happened to me in the past as well. Like the robot gets confused about, say, like all the people with my pseudonym. So yeah, I don't totally recommend this, but if you have a pseudonym, um, you can go Google your pseudonym and you can find out all the things that you've been doing on the internet. And what'll be interesting about that, and this happened to me once when I did that, is that the agent will assume that that entity is a unified entity. That all of the people called Rainydan are the same across all of these different social media platforms and art websites, or you know, you name it. And so in real life, I'm also named Dan, and there's a lot of Dans out here. There's so many Dans that at my old work, we had a Slack channel that was just Dans. And you could enter that Slack channel if you were a Dan. And there were lots of us. And so if you want to hear about like the exploits of Dan, you know, you're gonna get a lot of material. And even for Rainydan, there was like some stuff that I had never done or heard of, and it took me a minute. Oh, it's merging everything together. It's all in one big soup, and it assumes that if you're talking about the individual Rainydan, that all of those activities are consistent. And there was sort of like a land grab for that alias, and then it was used everywhere. But no, that's not. There's a lot of coincidental Rainydans out there. Um, Cool. So anyhow, sorry. Getting back to this, we had this thing called simplifier, and it was in charge of certain like quality control. And when the formula for antiquarian was written, it wanted quality control, and it's like, oh, you do quality control. It's true, but it's not true. The context is wrong. It's like a context merging, crashing, clashing. You know. Okay. A solving grid rather than a spatial board. I mean, all of the stuff we're interested in pretty much has spatial board. There is a really cool, not to harp on 14 Minesweeper variants too much, but there is one in the second game where there is both a mining board, if you want, that has mines and safe spots, and then there's another sort of logical board that you have to sort of use along the way. Um, so, for instance, if you're doing there's a version of that puzzle where instead of doing mines with counts, with numbers, they're sort of cryptograms, and they say letters, and you have to figure out as part of the puzzle um, which letters mean which numbers. And there is a solving grid for that. Um, and I guess we will talk about that. Okay, sort of repeated here. Um, cool. There are a couple of threads now. It's good that we got sort of some signal back on our refactoring, which seems to have gone well. Um, great. Let's do yeah. Let's save that work first. That seems smart. It was asking us about how to QC all of those too. I'm sure we'll get around to that as well. But yeah, it's too bad that it keeps feeling that it needs our attention to do stuff, because that's a slow process, right? Getting our attention. All right. So the window's actually open for World Puzzle. I'm going to pin this again. If you guys want to compete in the World Puzzle Grand Prix, there is a puzzle round open right now. I guess the designers were from Japan. And then what we've got here is the instruction book, a link to the instructions for this round. And the way that it works is that when you feel that you're ready to go to it, you go ask for the puzzles. And I think there's an honor system. I don't think they ask you to do it on video or anything. But you're intended to work the puzzles with pencil and paper and you only get 90 minutes, and you're going to get like 30 problems, and you do as many of them as you can. Now I consider this one, we've done a few other pages. This one has been the hardest one so far, I think. Star Battle right here. Maybe it's just because we haven't practiced and we don't know all the rules, but as a refresher, we're supposed to be getting 2 stars in each row and column and region. Exactly two rivals. And the only restriction is that if you place a star, then there can't be anything else in the 8 neighborhood of that star. I forgot we placed another star. That would imply that this 8 neighborhood was taken out. So we really only have 2 places left for this star in this region. Be here or here. And they do have an overlapping place that if you put a star here, then we couldn't use either of those, and we wouldn't be able to get 2 into this region. All right. We're getting pretty close to requiring both of the stars to be in this region on this row. If this one isn't a star, then these 2 have to be taken. That seems a little wild. So what I'm trying to do now, if I were on my computer, well, if I had some more undos, I guess let's just pretend that we do have some more undos. Oops. Sorry, weird click there. Um, let's do this hypothesis in yellow. This would be hard to do it with pencil and paper. We'd be like constantly erasing and who knows. And none of this. Yeah. Okay. So it wouldn't be this one. And then we would need to get 2 into this column, and that's almost needing 2 from this single region as well. And we're almost needing 2 on this row from this region. Oh, but it can't be 2 because there has to be 1 here, and that means that there can't be 2 here. There has to be 1 here. That would take out these. And then this. So we'd have to get 2 in here. We would take out both of these. No way to make 2 up here without taking out both of these. And we'd be left with this. That would make 2 in the column, and we need 1 right here. And then there's 1 right here, so there's none here, here, here. We would need 1 either here or here, and they have an overlap right here. Oh, but we would also need 1 here or here. So these would actually be diagonally across from each other. It has to be one of these, but at most 1. That means it has to be one of these. This region. And then it would have to be one of these 2 right here. Oh, we put a star here, so it's got to be here and here. That forced us to put a star here. No and no. And then if we can have at most 1, we need to get 2 into this region, but we're going to have 1 right on one of these 2. And then we can only have 1 on here, so that means the other one has to go here. This would be taken out, and the only way to get 2 stars into this region is like so. And remember, we were doing all of this on the hypothesis that this is not a star. That's the fact that we're trying to learn. So we wouldn't take this one or this one. We need to get 2 into this row. Can't use this. Got to be one of these 2. These 2, these 2. They're all really closely related to each other, right? I guess looks like we eliminated all but this one for that region. Got to be this one or this one. We're not sure which one. If it were this one, then we would have to take this one right here. And we'd have to come down here and here. There. I think that works. I think this is a full solution. Oh, we need to get a second one into here. Did I do that wrong? I think I did. This is right. I think I said this backwards though. find this one. This is sort of hypothesis 2. Technically, I should be doing a different color. Okay. This one will be blocked out. Then we have to come here and take this one to finish out this region. It's the last one in the region. And we have to come take this one to fill out those 2 rows. And then we have to take this one. And I think that we've derived a contradiction on the second hypothesis because there's nowhere to put the second one in row 5 and second one in column 3. They'd be like too close to each other. Yes. So that's kind of an issue. So let's rewind to when we put in this guy. That doesn't work. Now we're trying the other one. And if this doesn't work, we're rewinding all the way back to this one right here and putting a star there. Okay. So with this in mind, our moves are a bit less forced, but we do have to put the star down here, just owing to what's left in the column anyway. That's kind of interesting. It's like we should have looked at that fact first. I'm gonna put one here. Nothing on this row. Not this one. I think the last one left in this region is here. And we'd have to go here. Finally, here. And this is one of those things about the only one solution deal. I think that we can check this and see that it is an acceptable solution. I'm just scanning through it now. Sure. For each row, enter the number of the first column from the left where a star appears. Use 0 for column 10. Okay, this would be 2, 6, 1, 7, or 8, sorry. 8. Oh wait, 6. It's in a different color. So this is another problem. You get the right answer, and then you fill in the wrong answer. 2. This time it's 7. 1. 3. And 5. 2, 6, 1, 6, 2, 7, 1, 3, 5. Yeah, so any solution is a good solution. And that is, yeah, their solution too. This was a really rough one. I think that we learned a bit more as we were going, but we did need like a hypothesis test to kind of get over the finish line. All right. Okay. We've got tutor getting it. Okay. I made a repo at for tutor. You should be able to use that. Yeah. Okay. Let's answer all the questions. Review routing. I think the simplifier is a stand-in for a different kind of QC activity. Maybe we can come up with a good formula to QC that would cause a sufficiently skeptical to QC the staging entries QC is quality control. You do a good job. Um, One thing that's a little tough to know is how much information you need to vet inaccuracies in an entry. Like, do you need to prototype an entire game just to ensure that the rules or mechanisms are transcribed appropriately? What kinds of sampling might one do? How can we create ground truth around the catalog entries? Feel free to think of some consistency metrics. Consistency and error metrics. Okay. I think it's great that there are 30 vocabulary proposals. I'm not a mathematician, but I have a little. So if I am going to be involved, I might need a certain amount of context setting around those proposals. The presence of a solving grid. I have seen some puzzles that incorporated it, but I tend there's probably a name for the kind of puzzle that you do when you're solving what they would have called logic problems in Dell. Um, yeah, some people call these logic puzzles. Um, hmm, I'll try to find the grid. Maybe we need to find one that's slightly harder. Okay. This seems like a good example to me. And unfortunately, there might not be a good name for this. I would tend to call this a logic problem, probably. And so, yeah, if you've ever seen one of these before, the basic idea is that we have a bunch of clues and we're trying to identify who did what. And so we have these four different dimensions, right? Which couple, which position they did in their puzzle putting together competition, how big their puzzle was, and what was the picture of the puzzle. And over here we have all the clues about. Oop, no, I didn't. I didn't solve those clues. Yeah. Over here we've got all the clues about how these things are related to one another. And the idea is that if you follow all these clues, your solution should follow all these clues. There will be exactly one solution that fits all of the clues. And yeah, you can put it together logically from all of this. You can start to cross out or accept. Like if you can deduce that whichever puzzle had 700 pieces came in first, not knowing any of the other information about that 700-piece puzzle, then you can mark it off and etc. So I think this might be like familiar to some people. Don't want to belabor that. They are more associated with what? Let's see. Let's see if Dell calls them something in particular. Logic grid puzzles? Yeah, I think so. With logic grid puzzles, which are essentially um, asking to solve all the relationships, which essentially asks to use um, word problem like clues to assign values to a bunch of Boolean relation, like which sandwich at the fair won first prize. What was its con to user to deduce the values of a bunch. What was it? What was its condiment? How many? How long was the standing ovation? Won which prize? That's not. We're not really doing. We could park those in a different category. There we go. Okay. Uh, okay. Uh-huh. Open to continuing the refactoring once tutor is in a repo and all of our code can be rewound. Okay. So yeah, that's Jigsaw Night. I like these. They're fine. I think, come to think of it now, I wonder how easy it would be to kind of this one is interesting because it says last names and a lot of the clues are using first names. So the first names, like who has which. Oh no, never mind. Harry and Mark is Hark. Phil and Melody is Phility. Never mind. Benevieve. That's funny. Never mind. But anyway, I think that we've seen as we've gone through a lot of our puzzle grids how potentially hackable they are to like trying a hypothesis, seeing if it works, and then moving on. I mean, you can start to put like really simple clues. Harry and Mark did not come second. The Tower Bridge did not have the most pieces. Um, of the couple with a 700 piece puzzle and the couple who came in third, one is Benevieve, and the other had the cottage garden puzzle. So one thing we can deduce right away is that 700 was not third, and Benevieve did not have the cottage garden puzzle. Um, but the other thing that we want to do that's harder to represent in the grid is that, if 700 is Benevieve, then third is cottage garden, and vice versa. If 700 is cottage garden, then third is Benevieve. So that's a little bit more difficult to work with. Ability had at least 1,000 pieces. Good info. Um, Four of the five couples are the couple with a 700 piece puzzle. They've been mentioned twice now. The couple who came fifth, Duranda, and the African Safari. So we can go through all of these and just none of these couples are the same, right? Duranda didn't have the 700 piece puzzle. The couple who came in fifth didn't have the 700 piece puzzle. Uh, let's see. The African Safari wasn't the 700 piece puzzle. Yeah. Um, and then likewise, the couple who came in fifth wasn't Duranda. The couple who came in fifth didn't do the African Safari. Duranda didn't do the African Safari. And this is all surface level stuff, right? Like, these are providing us with kind of pigeonholes that are very useful. If Phility came second, then the couple with the cottage garden puzzle did not come first. So the couple with the cottage garden is not Phility. It's good info. Again, oops, undo. How do I undo? Undo. Okay. That sucked. Definitely wanted to undo. Um, 1,200 piece puzzle, not Benevieve. And we cannot do anything with the other clues until we know if Phility came second or if Benevieve had the 700 piece puzzle, which is definitely like on the table. They're one of the three ones that could have it. The couple who came first had a puzzle with 100 pieces less than Duranda, who had 100 pieces less than the cottage garden. So this is a good clue that the cottage garden. Um, so there's this 12. Most of these are separated by 100, but except for the largest one, which is 1,200. So the largest one that the cottage garden could be is 1,000, and then Duranda is 100 less than that, and the couple who came in first is 100 less than that. So that really only allows for two different runs. We've got either this is assigned to the 10, 9, and 8, or the 9, 8, and 7, right? Um, so that means the couple who came in first was 7 or 800. Um, the couple Duranda was 800 or 900. And Cottage Garden was 900 or 1,000. Okay. Um, Moroccan Rooftops was completed before Tower Bridge, but after Taj Mahal. Um, so that means that Taj Mahal can be first, second, or third. Um, and then Moroccan rooftops can be second, third, or fourth. And Tower Bridge can be third, fourth, or fifth. And we just know that because of who's ahead of whom or behind whom. Harry and Mark were quicker than Dan and Jennifer, but not as fast as Ben and Genevieve. So we do kind of the same thing again. Ben and Genevieve could be first, second, or third. Harry and Mark could be second, third, or fourth, which narrows it down quite a bit. And Dan and Jennifer can be third, fourth, or fifth. All right. So you can see, like, just taking all of these puzzle clues at once, we're not totally sure um, of any one piece of information. And you're like, have we learned anything? um, we have not yet learned that. Oh, well, I think we do know that the cottage garden puzzle has to be pretty big, right? Or, yeah. It actually, so cottage garden, we've narrowed down to 900 or 1,000 because of one of these clues. And so we actually can come back up here to number 2 and say that the cottage garden one isn't the 700 piece puzzle. It has to be the one that came in third. That's some good info there. And then we can kind of try to transfer that around. Um, yeah, unfortunately, there are no more X's to sort of transmit around the board from this, but you could see that, like, since cottage garden isn't 700, and we could since third is not 700 and third is cottage garden, we'd know that 700 is also not cottage garden. That kind of thing. Mm, okay. QC framework. Yeah, it describes puzzles as to play them. Cool. Seconds. Sample. QC. Some error metrics. Yeah, molecule staging QC. Yep. Great. Yeah, sounds this is good. Yeah, you can we can continue on all those threads. Agree that we can use a user-friendly vocab proposal. Um, hmm, if that's a good job to regularize, let's make a formula for that too. Why not? Um, the reason I like the formula approach to this kind of thing is that if you're gonna do something 30 times, you're gonna get a pattern, and hopefully you're going to learn something from doing that over and over again. Oh yeah, how's our logic puzzle doing? We're definitely curious about things where we've narrowed things down a lot. If cottage garden is third, oh, well, here's another one. We can transfer the stuff about cottage garden to third now too, right? We know that Cottage Garden isn't Philody or Benevieve. That means they can't be third because Cottage Garden is third. And we know that Cottage Garden is 900 or 1,000. So that also means the third place is 900 or 1,000. Okay. Um, then we also, the second half of this clue, the part that we figured out, is that Benevieve did 700. Yeah, again, useful because we know that 700 then came first or second, maybe fourth. We know that 700 isn't Cottage Garden. I think we already knew that though. This kind of thing. And any time that we eliminate sort of four guesses in a certain row, then we'll know, you know, that it has to be the remaining one. Bill and Melody did at least 1,000. That's still in the grid. Tower Bridge didn't have the most pieces. Check. That's over here. Okay, four of the couples are the couple with the 700-piece puzzle. We know who that is, though. That's Benevieve. So Benevieve did not come in fifth, and Benevieve did not do the African safari. There we go. All right. And of course, Benevieve isn't Garanda. But if Philody came second, then the couple with the cottage garden puzzle did not come first. Now, notice how we can't really use that in reverse, right? We can't say that, well, they did come first, so Philody is not second. If Benevieve had the 700-piece puzzle, they did. Now we can go on to use this. Then the 1,200-piece puzzle is not the Moroccan rooftops. That's good too. So the 1,200-piece puzzle has to be either the African safari or the Taj Mahal. All right. Gerard, did I skip this one? Gerard and Amanda didn't come first or second. Uh, oh, Harry and Mark were quicker than Dan and Jennifer. That means that Dan and Jennifer can't have come in third because there's no way for Harry and Mark to be quicker. That means that Danifer didn't do Cottage Garden. And also means that they didn't do, well, it doesn't mean they didn't do the 9 or 100, 900 or 1,000. A vocab reformula. Good. Okay, cool. Let it cook. It's like at this point that I sort of feel like in some of our puzzles, right, we just start hypothesizing. Oh, well, what if Duranda was fourth? And that would cause a whole bunch of chain reaction things, like Danifer would be fifth, and Hark would be third, and then all this stuff would happen, you know. Um, and that's definitely a way to solve our logic grids. Um, but we don't have undo, and so that would really suck in this context. Um, let's see. The couple who came in first had a puzzle with 100 less than Duranda. Yeah, it had to be 7 or 800. I think that's still reflected. Duranda had 800 or 900. and the cottage garden puzzle was 900 or 1,000. Still, this is all still static. Harry and Mark were quicker, but not as fast as Genevieve. Okay, so that's the same. Gerard and Amanda didn't come first or second. Now I see why you might want to do solve clues. Some of these are like really simple. Like, we're not going to learn anything further from them. It's all in the grid now. But this four of the couples ones, we haven't like identified all four couples. And they'll have to be different couples. Who could have come in fifth? Jennifer or Phility? So we've got Benefieve, Jennifer or Phility. Not possible for Hark to be the one that came in fifth. I think that we've saturated that one too. If Moroccan Rooftops came in second, that would imply that Taj Mahal would have to be first. And then we don't know when the Tower Bridge one was. If Moroccan Rooftops came in fourth, then Tower Bridge was definitely fifth. Yeah, I feel like there's probably enough info to solve the puzzle. Like, maybe there's just stuff that we haven't transferred around everywhere. Hmm. Let's do this one again. If Hildy came in second, then the cottage garden didn't come in first. But I think that we already know that. So this clue doesn't really help us. Hmm. Well, if Taj Mahal is second, then African Safari has to be first. Moroccan has to be fourth. So, yeah, maybe we should try and explore this world a little bit. Taj Mahal second. Then we have African Safari first. Moroccan rooftops fourth. Tower Bridge fifth. What does that do? That definitely satisfies clue 9. The couple who came in first, that would be AS. The AS doesn't have a 700. That puts it in the 800, 900,000 range. That would also mean AS 800, Duranda 900, Cottage Garden 1,000. If TM is second, maybe that's the way to put it. TM. This would be a lot easier with a piece of paper, I think. Okay. It's funny. Why would you name it the pack puzzle when the pack it's incremental, you know? But whatever. It's complaining about context. Maybe we do need to reset. If we're going to do that, then we should probably be doing our Yep. Always more Claude code. I'm glad that that didn't get interpreted as yes. That would be confusing if we had our Gas City repo as a rig in Gastown. Maybe I should uninstall Gastown. It had its time. It was training me, preparing me for this project, but yeah, we haven't used it in quite a while. And we can go through and look at all of the good place to stop. Okay. It's weird that it doesn't have a handoff command. Um, yeah, I really thought there was one. Uh-huh. Hopefully that's good enough for it. So in this world where Taj Mahal is second, we'd have AS 800, Cottage Garden 1000, Benevieve have 700, but they don't have African Safari. That's still consistent with this. So which one do they have? Oh. No, it's more like the other way around. Since Benevieve came first or second, and African Safari came in first, they don't do African Safari, therefore TM is Benevieve. I feel like I'm starting to go slow. Miranda did third or fourth, so they're either CG or MR. That's not eliminated. Third was Cottage Garden was Garanda or Hark. If Benevieve didn't come in first, then Phility had to come in first. Actually, we have a situation here I should have noticed before. So notice that both Garanda and Hark are the only ones that can be third or fourth. That means nobody else can be third or fourth. Only these guys can be first or second. That means Danifer is fifth. There we go. In this world, that would be down here. It would look like this. Huh. And look, that power bridge got eliminated at some point there. So Danifer did fifth. They did Tower Bridge. Transfer that around. Tower Bridge is not 1,200 pieces, so they didn't do the 1,200 piece puzzle. And it didn't come in fifth place. Okay, so the session possibly detached. I didn't see when it did. But yeah, let's hope for good things. And let's see if it's, I guess we could actually do one of these first. Whoa. Not what I expected. Maybe it was a startup issue. But yeah, if we had undo, then I'd be pretty happy with this. Four of the couples are the couple with a 700-piece puzzle. That would be Benevieve. The couple came in fifth. That would be Danifer, Garanda, and the pair with the African safari puzzle. So none of those people in this world, Ben, Dan, or Garanda, had the African safari puzzle. It had to be either Ability or Hark. Yeah, I mean, that's true. I'm pretty sure that this clue is now useless. I feel like we must have enough on the board to evaluate this solution, but I'm too slow. Why is this happening? Doesn't seem good. Hopefully none of this is happening because we moved our directory for incremental beads. One could imagine that to be possible. We can also restart our city. Okay, not good. Okay, let's try one of these. So far, nothing too scary, I don't think. Also, on the bright side, um, we have everything in our Git repo, so we might be able to figure out how to roll back. Okay. Feed store ping. Exit status 1. One thing that we could try to do is you know, can update our fork again. See if anybody's having issues in the Discord, that kind of thing. If the city's really not running, then we can also like reboot the VM, see if that helps. If we crash feeds somehow. A lot of RAM just for Dolt, I would think, but nothing too crazy here, I don't think. Hmm. Yeah, it seems to think that what we did to the incremental rig is okay, but something's wrong here. Is BD list the smallest? Okay. Well, let me do some secret stuff for a second. Let's enjoy the diagram for a little bit longer. Okay, that's nice. We got a new version of Claude code in the time since we started running this session. We updated our fork of Gas City. We could potentially rebuild it. Okay, cool. Okay, I think I did the. I think we're good to the point. Oh, that's interesting. Hmm. Um, right now I'm telling Claude about this problem, and we're going to see if we can get it to figure out what's wrong with beads. I'm gonna go to the beads directory real fast too, and make sure I have the latest. Okay, the homebrew one's getting used for beads 1.0.5. Okay. All right, I think we're to the point now where I can put the camera back on, no problem. Or the, yeah, I just I got a little wigged by something I saw the CLI doing sometimes, which was like showing my personal email address, and I don't know how to change that yet. So now we're back to regular old Claude. Sure. All right. When we drop into a vanilla Claude session, we don't have dangerously allow all on, which, maybe that's normal. Okay. Hmm. Dolt again. It's true. Most of my problems with Gas City have ended up being Dolt related in some way, but we haven't noticed much the last few sessions related to it. All right. Have we gotten ourselves into a tizzy on our puzzle here? If CG were 3, it's got to be Arc or Duranda. That's still in our puzzle up here. Oh, we know that CG was 3rd, though. Is that right? We don't have too many options for this. We've got either TB or we've got MR. And similarly here, 1200. But we know that Tower Bridge can't be 1200. No, we know both of these can't be 1200. That's weird. So this seems to there seems to be a contradiction here somewhere. That if Taj Mahal if AS were first, we know it can't be 700. But first has to be 700, 800. So AS is 800. That's correct. AS is first and 800. And that implies that Taj Mahal is second with 700. Yep. That implies that Cottage Garden is third with 1,000 because of this 800, 900, 1,000 thing. Then we have to have Tower Bridge or Mark and Rooftops 1,200, but it's not possible. So therefore, we can't have Taj Mahal in second. We have to have it in first. That's the hypothesis we're trying to build toward, I think. All right, so let's rewrite this in terms of that. So yeah, some of this might be wrong. We gotta go redo it all again. Taj Mahal first. Then we've got well, maybe 2, 3, 4, 5. We've got Taj Mahal, Cottage Garden, Tower Bridge. How's Claude doing? Hmm. That's fine, I guess. I don't like giving it permissions like that Just do whatever you want with GC Dolt and GC Beats. That's not, those are broad ranging commands and permissions that I just gave. Okay. So it's AS Moroccan rooftops, AS or Moroccan rooftops. Blue 9 is sort of vacuously true, since this is first and this is fifth, right? African Safari is second or fourth. Taj Mahal have 700 or 800 pieces. Tower Bridge came in fifth. It cannot have 700 or 1200 pieces. Only Taj Mahal or Moroccan rooftops can have 700 pieces. The only way Moroccan rooftop can have 700 pieces is if it came in second. Cottage Garden doesn't have 800. We already did that one. Taj Mahal doesn't have 900, 1000, or 1200. Therefore, African Safari has 1200. African Safari came in second or fourth. And it was either Philody or Hark. The couple who came in first had a puzzle with. We still don't know, do we? Oh, okay, so we know that only Philody or Benavieve can have Taj Mahal. Because they're the only ones who came in first. First try. Okay, let's try restarting Dolt only. It's giving it a minute to come up. I guess we're seeing how slow I am at these. Again, there's no undo. We're writing everything in pen, right? Cottage garden is 9 or 10. If I were just drawing on this, I'd be having a better time. Anyway, I do want to finish it, but I feel like we spent so much time. That's not good. Did BD list work? Like, can I do it? It doesn't look like it's working. You can do that particular command. Ah, and then it finally did work, but it still seems to be unhealthy. That's fine. Fine. This is the dirty underbelly of Gas City, for sure. Maybe we should, yeah. We diverted into logic puzzles. But I am trying to prep to actually do these puzzles. shade some cells. Like, there we go. Each region's shaded cells must have rotational symmetry, or none. So that all cells are connected orthogonally. All other cells are connected orthogonally. And no two shaded cells share an edge. So the unshaded cells no word may cross more than one thick border. And that's like this way or this way. They must have rotational symmetry. So let's start over here. A nice looking brush here. Okay, that'll be fine. In this one, we need to have one cell shaded. But the only place to do that can have rotational symmetry about the center is in the center. All the other ones, if you put one in one corner, you have to put one in the opposite corner. And that makes two. Now, what does it say about this? So that means that none of these would be occupied. And it would mean that if this one is unshaded, then this one has to be shaded. And same for this one right here. No two shaded cells share an edge. So we were able to do this because we knew the size of the region. But here, we don't want to be looking at their answer either. I guess the thing that's stopping us from just shading in two cells in this region and then calling it good is that whichever two we pick, we're going to have to block them in other parts of the region. So, for example, say that we pick this one and this one. Not only do no two cells share an edge, I'll use this as the red hypothesis. So this can't be used. But also, it needs to not be blocked orthogonally. So it's going to be like this. And keep in mind that because we shaded those two corners, all of these other ones are open. So we have to stop this one here. No doubt about that. Then we know that these don't share an edge. And this doesn't share an edge. So we have a problem. This word is about to cross this boundary. So we fill in this. And then we have to give this rotational symmetry. So it has to go like so. We have to give this one rotational symmetry as well down here. Okay, so we have a couple of problems starting, but here we solve them. This would be the third region for this word. and like so. Um, that does cut off this word from going too long. And now I think the only word left that's going to go too long is right here. But we're not allowed to color in these two. So this is where this is the contradiction right here. We can't have the two shaded cells next to each other. And in fact, we could line those out from the start of all of our solutions. And we can't put anything next to this one. So this violates the word crossing more than one thick border. So with that hypothesis in mind, and this is hard to do on pencil and paper too, so. But right now we're just trying to understand the puzzle type a little bit, I think. All right, but we did get an inference out of that right here. I think this was also a useful inference that if this were to have rotational symmetry, then we'd have to color in two cells next to each other, and we can't do that. So this one actually has to be used. So does its mirror image here. Stop these from becoming long words, we have to color in this one and this one. And to preserve rotational symmetry, we have to color in this one and this one. All right, now we're cooking. That was really helpful down there, this bit. Okay. We have to release these, the wild. Right, because we can't trap any of the white area apart from the rest of it. It's like a big ocean. We need to be able to cut this column off either here or here, and same for this column, here or here. And similarly, we need to cut off both of these words. This would not be sufficient. That would work okay, I think. So put a blob here and here, and then a blob here and here. I think that would take care of the whole thing. But then, of course, we have to do these. We have to get two in here. We can't pick the middle, actually. So we know we have to do these. Oh yeah, then we have to cut this one off for sure. Rotational symmetry. Go. And then we have to stop this one from becoming a long word. Okay, that's not so bad. The stuff with two in the center not being usable is interesting. I think that's probably the place that you start doing your inferences. And of course with this gimme like this one. Did we get their answer? We sure did. Okay, so I'm thinking we're understanding that one. Right. It's figuring out some sort of Dolt migration that we need to do in order to be happy again. All right. On to the next puzzle. Don't look too hard at the solution again. But I don't know the rules of this, so that's going to be a challenge. Yeah. Don't want the answer. Please, thank you. Well, it's going to be hard to... Here. Not working great. Maybe I can do a filled box. I haven't used this program very much, so we're all learning together. There we go. All right, we got there. Cool. Oh, and I did a gradient on the whole page apparently. Oh well. Okay. Shade some cells black, leaving the other cells white. The grid is divided into non-overlapping regions. Every white circle must be in a white region. Every white region must have a square shape. Every black circle must be shaded. All shaded cells must be in the same region. No 2x2 group of cells can be shaded black. Okay. Hmm. I think we're learning things like if you, so this is black, shaded, dark. This is shaded and this is shaded just to start the puzzle. This is shaded too. And this is shaded. We can't make a white region through here because there's no way to turn this back into a square. This is going to be white. And yeah. So this would have to be shaded. But then this one has to be white because we can't have a 2x2 area. And then this one has to be black because that has to be a square white region. Right? Are we getting there so far? Okay, I guess stuff like this, these two are together. So they must be in a square region that's at least this high. Same for this. And the problem we're going to run into is that if we let these two regions meet, then they'd be too big. The white region would like cover the whole board. So we have to come in at some point. So if we came down again, then we'd make a 3x3 region. It'll be next to this white square. So it wouldn't be a square region. The one way or the other. So I don't think that we can come down on 3. We got to go like this. And then we can color around it because we know that's where it has to stop. Again, we're in a position where we can't make a larger region out of this white square. Gotta stop like that. We can't make a square region get in there. I mean, it sure looks like we could put a white square right here. And that would cover all of these. Then this would all be black. And then these two would both have to be white. And that would make this a square region. I think that satisfies the constraints. There are no 2x2 black areas, and all of the whites are in a square area. We kind of made a leap of faith down here about this 3x3 thing, but I think everything else that we said was sound. Oh, I guess we could have said, you know, if we stopped our 2x2 here, it would have these white things sticking out. So we have to at least go out to 3. That would be another way to put that. Like if you're gonna draw a white region and then there's white things next to it, then you've got to keep expanding. Okay. I didn't find that puzzle super interesting, but maybe it gets more complicated. On to page 5. Let's see how the mayor, our temporary mayor is doing here. I don't think there's a new I don't know what they want you to say about shell commands. It's like either you read the whole thing and you understand what it does. I mean, they certainly didn't read the whole thing. Okay. Connect some orthogonally adjacent circles with bridges. Every number in a circle is the count of bridges connected to the circle. If two circles are orthogonally adjacent, they must each connect to a different number of bridges. You can't have two zeros next to each other. No two bridges can connect the same pair of circles. We're only doing orthogonally adjacent bridges. It must be possible to get from any bridge to any other bridge by traveling along connected circles of bridges. Okay. Let's start with the obvious one. 2. Okay. This one cannot also be 2. And it can't connect to the 0 bridge. Therefore, it has to be a 1 bridge. And it is. How are we going to draw these? 1. Okay. So it's done. This is done. A 4 bridge connects to everything. This is done. This is done. We only get 0 through 4. So this is a 2 or a 3. There's no way to do a 3 here, so this has to be a 2. This has to be the 3. And that means it has to connect this way. This 4 has to connect this way. This one's cut off. This can't also be a 1. It's got to be a 0. This one could be a 1 or a 2. Okay, that's the edge of the puzzle. Just checking. Putting these little X's in here to say there's no edge there. That's an old convention from like Slitherlink. If we left one bridge into the center here, I mean, this can't be a 0, so it's got to be a 1. That makes this one a 2. This one has 3 bridges going to it. It's a 3. That does seem wrong. But I feel like we were pushed pretty hard into this conclusion. Like, we had to have... Oh, we didn't have to have this be a 3. It can be a 2. It's just that the 1... It's not that the 1 has to have all 4 different kinds around it. It's just this can't be a 1. Let's do 2. I guess that doesn't work out either, though. This is interesting. Yeah, I think we gotta unwind all the way back to my mistake with the 1. Okay, try again. 2 goes like so. This can't be a 2. There's gotta be a 1. That's a good starting point. 4. 4. This can't be a 1, it's a 0. I don't know what my mouse pointer is doing right now. This one can't be a 4 or a 3. It's stuck being a 2. This one can't be a 0. It's got to be a 1. This one can't be a 0, so it's got to be a 1. This one can't be a 4 or 3, so it's a 2. This is just VM life right here. This is an interesting corner here, because if you draw a 2 here and a 1, then these would both be 1s. If you connect another bridge here, then that would be, these would both be 2s, and this would also be a 2. So you can't connect either bridge. It's got to be a 0. A 1. A 1. This is cut off, cut off. It can't be a 1. That's the only way out for it, though, so it's got to be a 0. Is this reachable? No. This little island out here has to connect out one way or the other, either through this route or this way. This can't be a 2, and it can't be a 1. It can't stop there. So it's got to be a 3. This can't also be a 3, so it's got to stop at 2. Right now, this can't stop at 1. It's got to be a 2. Right, so we'll put a 1 next to a 1, right? Doesn't that mean there has to be a 2 here? Weird, right? Did I make a mistake again? I mean, I think that's gotta be right. Oh, for some reason I drew a line here, but I don't think I should have. And I don't think that there is a line there. If this one can't be 1 or 3, it's got to be 2. There we go. And if this one can't be 2 or 4, it's got to be 3. Okay. This final one. So that one goes 2, 3, 2. So we've got 2, 4, 3, 2, 1. 1, 2, 0, 1, 0. Yep, sure enough. Okay, I think we understood it. We just had a stray mark there that was kind of messing with us. That was not bad. It reminds me of bridges quite a bit. Yeah. What's it looking for in downloads? Why are you looking at downloads? I didn't see it in the command. Oh, it's homebrew downloads. Okay, that's fine. Do I not have the right? Dolt? Hmm. Let's give it a second. Sorry, this is me doing a little Duolingo. Yeah. Sorry, I know this isn't scintillating television. I just really don't want my streak freeze to go away. Um, let's see. So I don't do this. I do this. Take that. It's nice. There we go. I'm not a very good elo at the chess, like 1300. Okay. Hmm. It's Dolt. Okay. I don't have Dolt. Let's not do the backup. Let's not lose 11 days of work. Um, Potentially pick the right version from. Do we know the previous version? Okay. Duolingo is very proud of me. Hmm. I earned the May badge almost accidentally, but with a couple of days left in May. I guess I should have looked on the Discord for any weird problems with Dolt. Okay, cool. Not the most fun evening. Yeah. Let's it's fine for this particular process, I think. Hopefully the puzzling was all right at least. All right. Key West we did. Takoyaki. We've got paths and skewers. They are not printed yet, but we got to make them. Paths, skewers, and circles are takoyaki. Like octopus balls, if you want. Paths must go through only white cells and don't overlap or intersect. Every white cell is used in exactly one path. So we have to use all of them. Each path must use exactly 3 cells with circles. Ends of each path must be in cells with circles. So we're going to have a circle in the middle, and then a circle at the end. No 2 cells with circles can share an edge. If 2 circles are in the same row or column, they must be on different paths. How many cells have circles? Okay, so not you. So, here, let's make you a little bigger. Not you, not you, not you, and not you. But 2 of you. We don't know how many skewers there are either. But we know that these are all going to be involved in some path. Look what happens if we try to put a meatball in the corner. We can't put a meatball next to both, but we have to put both of these into a path. They have to go through this meatball, right? Ah, I guess also we know this. The only way they're not going to go through is if there's a meatball that stops it. So there could be a meatball at one of these corners. We're not sure about that yet. But it's possible that there's a meatball here. There actually has to be a meatball in this corner. because that's the only way to get there. You can't have a dangling skewer. Got to be on the end. So there's our meatball number one. There's no meatball here or here. Whenever there's no meatball, then you can be sure that there's a path, right? Because you have to be on a stick. Okay. If there is a circle in the same row or column, they must be on different paths. So if there is a meatball here, then these two can't join. We have to have a meatball here in the corner. We don't know if there's a meatball here. Yeah, I'll have to like I don't know, mark corners or something. Because we're trying to notate two things in the same square, right? I kind of like how that looks. It's making it look a little bit 3D, raised up like on a grill. When we come from that corner. They, if there is a meatball, there can't be one in the next one either. We do know that. If there were a meatball here, there'd have to be two meatballs here and here. I'm not seeing a way to do that yet. The problem is that we need three. Right? See, the problem with putting, you could put a meatball here potentially. I mean, the path's definitely got to go this way. No choices about that. But whether these are actually all part of one stick or not is not obvious. Right? And we don't want to see their solution peeking out at us. It would be nice if we could like highlight the edges that we're gonna use for sure. And then highlight the centers that we're gonna use for sure. The thing about has to begin and end with balls is helpful because if we know that we have two next to each other, they can't be the ends, so they have to be connected. Two non-balls, right? These are non-balls. Well, if there's an edge between them, it could be part of two different sticks, but in this case, since there was only one path for each, we couldn't sort of cut it off between them right here. They had to be connected to each other. Okay. Why are you doing this? um, hmm. This takoyaki one is quite weird. I don't think I've. No two cells with circles can share an edge. If two circles are in the same row or column, they must be on different paths. I guess one thing that's kind of interesting about this is that we can prove that because of this 2 in the corner here, we're going to have to be in the same row as some of the ones in this 2 over here, because we're covering 3 of its meatball spots with at least 2 of ours. Well, correction. We could put one right here, and then there'd have to be meatball here and here. These would have to be on 2 different sticks. Let's do that world first. Let's try the world where I'm just gonna try and rewrite a little bit of what we know here. We know this, we know this. Let's pretend that we know this. It's gonna be our hypothesis right here. So this is not a meatball. These have to be on 2 different sticks, so they can't both join this way. Gotta be meatball here and here. We already knew that there had to be there can't be meatballs here, 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 here. We knew there had to be one here. And we know it has to be on a different stick than this one. This can't be where it ends, it has to continue. Can't go this way, so it's got to go this way. We don't know for sure. Oh yeah, I guess we do. The funny thing about these ends, right, is that we can't cut this off at this meatball right here because this has to take part in a path, and it would just be a dangling stick on the end. So it's got to be part of this, and this has got to cut off like right here. So this would be like one of our sticks. This one has to turn aside here. Can't cut off stick between stick. We gotta just keep going. This might be a meatball. And this can't be a meatball, then this would have to go like so. It could go like this. Like so. Is there an ambiguity about where to put the last meatball? Could be in this corner, or it could be in this corner. That would, I think either way would satisfy all of the rules, right? We've used every white cell. We're going to have 3 meatballs, this end, that end, and this one's going to be somewhere in the middle. Keep saying meatball instead of takoyaki. Each path uses exactly 3 cells of circles. Ah, if they're on the same one, they must be different paths. That's the rule we'd be violating. So if we stuck it here, but it was on the same path as this, that'd be a rule violation. But it would be a rule violation if we stuck it here too. Maybe I haven't figured this puzzle out. Or maybe this one is impossible. Yeah, I think that's actually the deal, is that we've found a contradiction by sticking a meatball right here. So let's go backward. Yeah, I wouldn't want to say the puzzle's impossible. They obviously know what they're doing. So instead we'd say no to this one and yes to this one. Can't be this one. And all the things that we said about the stick needing to go in the corner, like there's no option. There's only 2 exits for these sticks right here. Right? And we're not like prejudicing like where we think the meatballs go by drawing in some of these lines. Perhaps later drawing circles on them. We gotta have this one. Not this one. Not this one. Gotta have this to get out. If we did pick this one, then it would have to be on a different stick and we'd sort of divert things around this way. If we don't have this one, then we have these 2, and they've got to be on 2 different sticks. Okay, hopefully it'll just find a few corrupted records and we'll be able to figure out what to do with it. There isn't one here or here or here. Yeah, I'm pretty sure all this has to be on the same stick. There aren't any on this row. That's kind of interesting. So we're looking for O for circular black, I is for straight, and L is for turn. Okay. I was curious about how they were going to notate the solution there. But yeah, still not trying to peek at the solution down there. Okay. So yeah, I do really believe that inference that there is no meatball here. I guess there's a sort of counting argument you can make too. We know there are going to be 5 meatballs in the puzzle, 2, 2, and 1. We know we need multiples of 3 in the solution, 6. So to believe in like 3 takoyaki sticks, we'd have to believe in like 9 meatballs and a lot of space in between them. And that's probably not reasonable. Oh, um, well, interestingly, like lanterns, we know that this one can't be a meatball because we can start drawing little X's maybe. I don't know the right notation. Because if it were a meatball, there'd be spaces here and here. There wouldn't be enough to fulfill the two. We know that about all the corners now. We've, well, these two corners. No meatball, no meatball. I guess we could do another hypothesis from here. Color, maybe? It would be about sort of the remaining meatball of these two. Let's pretend that we knew this one. We would know this, and we would know this, and we'd know that these two couldn't be on the same stick. So we couldn't make a turn this way, we'd have to go this way. And we have this problem, right, which is where's the third meatball going to go? Maybe it's this one. This one, to be used, has to go through this way. And this one, to be used, has to go through this way. There's no branching. And the problem becomes that there's nowhere to put this third meatball on this row to come in to this final stick, right? Like this stick could be completed by going like so. But then the third meatball is going to wind up here or here. It'll be on the same stick as the one in the same column with it. So I think that what I would infer is that this is not the case. Hypothesis that we did. And instead, the right one is there is a meatball here. And these have to be on different sticks. Watch the sticks kind of chase each other a little bit. Make them not meet. Then we're kind of off to the races there. They can't meet in a circle, so they've probably got to go like so. I suppose there's various ways they could maybe end. No, this doesn't work because these two would be in a line. They can't share a stick, right? So it would have to go like so. And I think there's no way to make this work. Am I missing something? Maybe the long hypothesis was going to work. Didn't read it right. This couldn't be a meatball because it would be, we'd have two middles. This would have to be an end. we're still in this sort of same conundrum, which is how do I get the third meatball onto this stick without putting it in line with this bro? This is an interesting puzzle. I think they're pretty hard. To get way back to maybe I'm messing myself up by drawing in these lines. It's a little hard to see that though. A second. We'll try to make this quick. It's definitely getting close to my bedtime. Seems to be linear scanning. This is something like what I would do though. I really hope this is it. We seem to be kind of back where we were before, although I'm. Oh, we're looking at sort of two worlds. We know this one can't be a meatball because it would preclude us from putting another meatball adjacent to it, and we need to do that to finish the two. So we've got either this world or this world. If it is this world, then we're in this two meatball world right here. There's still one mystery meatball. And we know that these two meatballs have to be on two different sticks. So I think that means we got to go here. And I think this has to be a meatball end too, because we have a meatball middle. And then we'd have another meatball end right here. This would have to bend. This would have to continue around. I think there's a contradiction here. No, maybe not. Maybe no contradiction, but yeah, I do think that we're back in the situation though where we need to get a third meatball for this long stick and there's nowhere to put it. So yeah, I'm pretty sure that that world doesn't work. We've done that twice now, and I'm pretty sure that that's like a confirmation. These ones would have to be together. That would make this one. This one also. The meatball. I think the 3D stick notation is kind of helping me out a little bit. Here's an observation. At least one of these has to be a middle. So it can't be both of them. That means that it's got to be here. Sure. Not a meatball. Um, and we have to choose which one we want to be not part of which stick. If we choose this one, then it's going to be on this stick. If we choose this one, got to turn left. Yeah, that's not a bad angle. Hmm. So if we know there's none in the corners, and it's got to be one of these two, we're faced with this question again. Where is the last meatball? And it actually has to be on the same thing, which means that these two are on two different sticks, I think. That means that this is a medium or a middle right here. It can't go on here because that would be two middles. So it would have to go this way. This one has to navigate between those two. Seems like they need to cross in a kind of funny way, doesn't it? Maybe not, though. Oh. We haven't determined which way these two need to go. This has to be another end if we have a middle and a middle. But we don't know which end. We would know that this stick just can't work no matter what. So this path won't go through here. They'll either go up or left. Can't go left because that would be like a 4 meatball stick. Gotta go up. Gonna be a middle on this though. Yeah, I don't see how it's gonna work yet. Maybe I made a mistake again. Um, hmm. This being a middle seems to be a problem. What about this one? These have to be on two different sticks, so this is one of our sticks. But yeah, again, there's no place to put that last meatball. Then we've got this one. They have to be on two different sticks, so this has to turn aside. This has to turn aside. How's this one supposed to end? Can't end on this one. Why did we say that they're, well, we can look at their solution for a minute. Why did we say there couldn't be a meatball here? Cheating a little now because this one's so hard. don't remember when we inferred that. Oh, we might have been doing it when we were trying to infer along with these lanterns. But yeah, I think everything up to here is good. These are well, this was a problem right here. Right here. This is a problem. Because we hadn't inferred that these were both skewers, we shouldn't have drawn the line between them. We should only really do that when we know that we've got like a skewer with nowhere else to go. Maybe that's the problem with the solution right now. This is a tough puzzle type. Let's come back to that one, I think. Naganawa. Locate some rectangles. Squares are considered to be rectangles. Go through the centers. May intersect other rectangles. Edges can't overlap. No cell can contain the corner of two or more rectangles. How many cells in the region are used by one or more rectangles? Okay, so not this one. This one. All four of these are getting used. This one's getting used. This one. I see. So if there's a rectangle that goes through this corner and can't go through this cell, it feels similar to takoyaki again. So one of these has been used. So we'd know that it can't come down here and then turn. That would be 3. The rectangles don't touch each other, even at diagonals or edges. All 3 of these are getting used. It's interesting. Edges can't overlap. How is this one going to get drawn? There. Oh, I guess they're going to have to cross, right? Right about here. it looks like to be a rectangle. Can't be a degenerate point. It's not obvious if this one, big one, continues to the left or not. It could, maybe. This is an interesting one because it requires that 3 be used. This is in a corner. This is also in a corner. But since this doesn't make a rectangle border, it has to continue. They can't share an edge or meet at a corner. Same rule here. Right now, if we just sent the line down, then they'd be sharing an edge or a corner. It seems more likely that this is going to be a really big rectangle like that. If that is indeed what it is, that would satisfy the 2 and the 3. We'd have to deal with this 1 down here. So for instance, sketching to here, that would take us, we have a couple of corners to deal with. We'd have to go here. Then we'd have to take care of this guy. It would look like this. I think that satisfies all the requirements, but I don't know if I logicked my way through the end of that. So if we take it back to about here. I guess we could do cases on which one of these to make. So say that we said this isn't a rectangle. We have to change course on this one. This has to be definitely can't extend it down anymore because then it would take up 4 cells instead of 2. So we'd have to start at curve, come through here, and yeah, we'd be running into problems with corners meeting or edges overlapping here, so we'd have to go like so, so. Yeah, and now there's just no way to draw that last square. So we would infer this one is used and this one is not. It would cause us to turn this way. Not overlapping edge, we'd have to come down like so. Still looking. I wish that I'd stick it on dangerously, just do my thing. But let's continue trying to reason a little bit. I think that experimental way was kind of helpful. If it were this one, then it would have to come out to the corners and make 3. So it definitely can't be this one. That eliminates this one. It would be dealing with this one and this one. I think I'm going to cut it there. Maybe I can figure this out offline. Yo.